There's an exercise teachers have used for decades to explain programming. You give a kid instructions to make a peanut butter and jelly sandwich, and then you follow those instructions literally. Put peanut butter on bread leads to placing an unopened jar of peanut butter on an unsliced loaf. It's a lesson in precision. Computers need explicit instructions. Well, except now they don't. Agentic coding using AI changes everything. Now you give instructions to AI and it writes the code. But is this just a fad? How is this different from previous shifts in the programming industry? That's the topic on today's Tech Thaumaturge. A history of programming is a history of abstraction. In programming, abstraction is just hiding the complicated stuff and only showing the simple, important parts that people need to use or understand. Think of it as creating a clean, easy-to-use version of something that's actually really messy inside. For example, when you send a message to someone, you don't need to know how the phone translates the message into data, how the server decides how to send it to someone, what happens if the receiving device is turned off. You just care about the fact that the message gets sent. We've spent 70 years finding ways to tell computers what we want without having to specify every microscopic detail. And we're about to take another huge leap, one that makes all the previous leaps look tiny. AI isn't just a tool, it's a new layer of abstraction. And understanding that framing will help you make sense of where the industry is heading. So here's a brief history of telling computers what to do. In the beginning, there was machine code, raw binary. You had to know exactly the voltage patterns to trigger which circuits. Programming was effectively electrical engineering at the time. Then came assembly language. Instead of writing 10110000, 011100001, you could write MOVAL 61H. Still incredibly detailed, but at least human readable. One layer of abstraction. Then high-level languages, Fortran, COBOL, C. Suddenly you could write x equals 5 and the compiler would figure out the register allocations of memory addresses, another layer of abstraction. Then came even higher languages, Python, JavaScript, Ruby, Java, automatic memory management, built-in data structures. You could focus on logic instead of plumbing. Each layer let programmers focus on what they wanted to accomplish instead of how the machine should understand it. Each layer made programming accessible to more and more people. Each layer made developers more productive. And now, AI. The lesson is that computers need precision, every step explicit, every assumption stated. But now I type, write a function that makes a peanut butter and jelly sandwich. And AI understands it. Not because it's magic, but because it's been trained on millions of examples of what humans mean when they say things. It bridges the gap between intent and implementation. That's a new level or a new layer of abstraction. So what does this mean for developers? This doesn't mean programming is over. It means programming is changing. When high-level languages emerged, assembly programmers didn't disappear, but the ratio shifted. Fewer people needed to write in assembly directly. More people could build useful things without understanding low-level details. The same shift is happening now. Soon, many tasks that require traditional coding will be accomplished by describing what you want to do to an AI. The AI handles the implementation details the same way a compiler handles register allocation, the same way Python handles memory management. But here's the crucial part. Someone still needs to understand what's happening underneath. When the AI generates buggy code, someone needs to debug it. When the abstraction leaks, and abstractions always leak, someone needs to understand the layer below it. High-level languages don't eliminate the need for low-level knowledge. They just change who needs it and when. So what's the new skill set? If AI is the new high-level language, the new layer of abstraction, what skills actually matter? First, clear communication of intent. The better you describe what you want, the better your results. This is prompt engineering, but it's also just communication. The same skill that makes you good at writing specs, good at explaining problems to teammates, good at rubber duck debugging, all of those things. Second, evaluation and judgment. AI generates output. You decide if it's correct, appropriate, secure, maintainable. This requires you to understand the domain. You can't evaluate code if you can't understand it. Third, knowing when to go lower. Sometimes the AI abstraction isn't enough. Sometimes you need to drop down a level and write traditional code. Knowing when is its own skill. The developers who thrive will be multilingual fluent in AI-assisted development and traditional coding. They'll move between abstraction layers as needed. If you want to prepare for this shift, practice explaining what you want before writing the code. Write the spec, the user story in plain English, in the description, and then implement it. This muscle will serve you well with AI tools. You need to get comfortable with AI coding or agentic agents. Use them, see where they excel, where they struggle, build intuition for when to trust the output and when to verify. Don't neglect fundamentals. Understanding data structures, software architecture, and system design matters more when you're evaluating AI-generated code. You can't spot what you don't know. Learn to debug AI output. When something doesn't work, can you figure out why? This is where traditional skills start to become more essential. Programming has always been about abstraction, telling computers what we want at higher and higher levels. AI is just the next layer. It helps us to express the intent in natural language and gets working code in return. This isn't the end of programming, it's the evolution of programming. The same pattern we've seen for 70 years, just accelerating. The developers who adapt will be the most productive ever. The ones who resist will struggle to keep up. And the ones who understand both the new layer and the layers beneath, they'll be invaluable. The peanut butter and jelly exercise taught us that computers need explicit instructions. AI is rewriting that lesson. Now computers need clear intent. That's a very different skill, and it's one worth developing.